Inside the BeeGraphy Editor, a node-based environment for executable design systems. Design software has historically evolved around the manipulation of geometry. Conventional CAD tools prioritize direct interaction with shapes, surfaces, solids, sketches, treating geometry as both the medium and the outcome of design. While this paradigm has proven effective for static modeling, it becomes increasingly inadequate in contexts that demand scalability, automation, and systematic variation. The BeeGraphy Editor represents a departure from geometry-centric tooling. Rather than functioning as a CAD application in the traditional sense, it operates as an environment for defining executable design systems. In this context, geometry is not authored directly, but generated as a consequence of structured logic encoded within a node-based framework. The primary distinction of the BeeGraphy Editor lies in its abstraction level. Instead of exposing users to low-level geometric operations, the editor enables the construction of parametric systems through interconnected nodes. Each node represents a discrete operation, mathematical, geometric, logical, or structural, while edges define data flow and dependencies. This approach shifts the designer's task from manual modeling to system definition. Design intent is expressed through relationships, how dimensions depend on one another, how constraints limit variation, and how parameters propagate through the system. Geometry emerges dynamically as an evaluated result of this graph. In effect, the editor functions less as a drawing tool and more as a visual execution environment. At its core, the BeeGraphy Editor operates on a directed computational graph. Nodes process inputs and produce outputs, forming a deterministic pipeline that transforms abstract parameters into concrete geometry. This structure enables a clear separation between input parameters, transformational logic, output geometry. Because the graph is executable, any change in input automatically propagates through the system, recalculating geometry in real time. This eliminates the need for repetitive manual edits and ensures internal consistency across all variations. A defining feature of the editor is the integration of constraints at the logic level. Constraints are not applied post hoc to geometry, but embedded directly into the system definition. This ensures that invalid states cannot be generated, as the graph itself enforces manufacturability, proportional limits, and structural coherence. By formalizing constraints within the executable logic, the editor reduces reliance on manual validation and downstream error correction. Design verification becomes a property of the system rather than an external process. Although the BeeGraphy Editor does not require textual programming, it is not a low-cognition tool. Effective use demands algorithmic thinking, understanding dependencies, abstraction, and data flow. The node-based interface lowers the syntactic barrier to entry while preserving the expressive power of computational design. This balance allows designers and engineers to construct sophisticated parametric systems without writing code, while still operating within a rigorous computational framework. The significance of the BeeGraphy Editor extends beyond individual modeling tasks. The same executable design systems authored within the editor serve multiple downstream contexts. Distribution through the BeeGraphy market, interaction via web-based configurators, automated export of production-ready files for manufacturing. In this sense, the editor functions as an infrastructure layer rather than a standalone tool. It provides a single source of truth from which design logic can be reused, deployed, and scaled across the entire design-to-production pipeline. The BeeGraphy Editor exemplifies a shift from geometry-driven modeling to logic-driven system design. By treating parametric logic as the primary artifact and geometry as an executable outcome, it aligns design practice with the requirements of automation, customization, and modern manufacturing. Rather than accelerating traditional CAD workflows, the editor reframes them entirely. It enables designers to move from drawing objects to engineering systems, systems capable of generating, validating, and exporting geometry at scale. In this context, the BeeGraphy Editor is best understood not as a CAD alternative, but as a platform for defining how design itself is executed.